Hi, everyone. I'm so excited to give you this talk. I had a lot of fun preparing for this. We are going to talk about telemetry as code, basically a solution we have created to enable declarative observability with OpenTelemetry. I'm Bence. I'm working at OXOFlow, where we are solving all problems related to observability, security. Lately, I've been into some SRE stuff, preparing for this conf. And I'm also a maintainer of two CNCF sandbox projects, namely Bence, a logging operator. First of all, I'm not an SRE myself. I'm a software engineer on a day-to-day basis. But I find myself around DevOps stuff. I've written a couple of operators in my life, and I'm familiar in Kubernetes. And this is how I usually imagine SRE people. They are so happy on their pager in the middle of the night. They are getting ready for the next page up and so happy in front of their computer. But while I was preparing, I wanted to get the feels of how does SRE people feel like, what's their problems, and what is the connection between SRE and observability, and really. So I tried to find the closest SRE folks I could find, and those were my colleagues at OXOFlow. And we had a couple of interview sessions, and this is what we came up with. So there's a couple of sentences that popped into my mind while I was thinking about what SRE folks do. But what ended up coming out from these interview sessions is that basically SRE folks are sitting in between two major front lines, helping engineering and technical folks. And on the other side, they are also having to help beyond that, marketing, sales, and so on, and also do some operational stuff. That qualifies for technical, but yeah, it's what it is. And this is how we are going to take this talk. We are going to see two interesting use cases of an imaginative SRE team helping around a technical bunch of people and a non-technical folks around. So let's get started. As I qualify for a technical person, I hope so, we can start with them. So first of all, how many SRE folks are we having in here today? You're working as an SRE or platform engineer, something. Could you raise your hand? Awesome. And how many of you ever worked with ingresses before, beyond deploying, configuring the log management, log format, or having to distribute ingress logs, something like that? Awesome. I saw 3 hands, so it will be interesting. So what's the matter with this case? In this presentation, this is the architecture that we are going to work with in the demo scenarios. Everything is running in Kubernetes. We are going to have these are basically tenants, but you can call them as namespaces for now. We have a front-end team, Argo CD, Prometheus, and we are going to have Perseus. I'm going to introduce all of those. And and everything is served behind an ingress. And if you're familiar with the log collection and log management within Kubernetes, so everything gets persisted into the nodes file system under warlog, pod name, pod UUID namespace, and so on. So it's easy to collect them. But on the other time, Kubernetes itself does not offer a native way for a node level log management. So there are a couple of projects out there to solve that kind of problem. So what's the matter with the ingress logs? They could contain sensitive information, should be treated carefully. You cannot just give them away freely. But there are times when teams are in need of information about when users hit their endpoint and what happened on that side. In our example, we are going to have that front-end team that requests access to a subset of the ingress logs, only interested in the ones that are destined to their front-end application. And the SRE team needs to find a solution to just give away only a subset of the logs and not all of them. And at that point, we are introducing telemetry as a code. Basically, this is a Kubernetes operator that we created. It's called the telemetry controller. We've solved the node-level log collection problem once again. And here it is. We like to tag it as an opinionated, convenient, robust API that can turn your telemetry event streams, logs, metrics, and even traces into Kubernetes resources. And it provides an isolation level somewhat similar to what you have with other Kubernetes native resources, pods, secrets, and other resources on the access control level for your telemetry data. For myself, if I had to pick a single point why I love this solution so much, is that we made it really hard to break. We had the chance to enable validation in almost all layers of this project. So starting from the CRDs, we are obviously validating our input data. One of the main goals when designing our CRDs was that we would require the minimum amount of input data required for us to craft a valid OpenTelemetry collector configuration. So that's the first. And after the configuration has been created by the operator, we are validating it through a bunch of OpenTelemetry validator pipelines. So we are checking for whether the IDs and the names of components are matching within the scope of the pipelines and such, and also static analysis on the syntax and so on. And once that is done, we mostly filtered out 75 to 80% of the issues that could arise from our handcrafted OpenTelemetry collector configuration, but there are also, we wanted to give an idea on to do some runtime validation for things you cannot catch. For example, if you're putting in a transform processor that you are using to transform some telemetry data, then you need some runtime validation to be assured that one of your transformation is not wrecking your deployment. So thanks to a recent feature, we were able to enable that. It's really under alpha flag, but it's something interesting. And by all means, at the end of this, you have just a couple of custom resources and you have a completely valid and really useful OpenTelemetry collector configuration. And if you ever had the chance to implement or adopt OpenTelemetry into a widespread infrastructure, you probably had nightmares crafting your own OpenTelemetry collector configurations from scratch, driving into the documentation, finding out the best processors, the receivers, and so on for yourself. So basically, the operator takes this off of your shoulders. The main component that is defining this operator is the tenant resource. So for the tenant resource, we have two major options in the spec. One is being the subscription and the other being the log source namespace selectors. So both of these are matching on labels placed on namespaces. So for the log source, you are asking which labels placed on namespaces you would like to collect logs from. And with the subscriptions are beings that you can use to route some of your, or the subset of your logs to your destinations. In our example, we are going to have a front-end team, a platform team, and we are going to have a tenant for the ingress. And for the front-end team, they are interested in their own logs and want to route them to their own subscriptions. For the tenant, they are obviously interested in tenant platform. They are interested in the logs coming from their managed resources, so the ingress, Argo CD, and monitoring for Prometheus, and want to route them to their own subscription. And for the subscriptions themselves, subscriptions are being that are routing logs based on an OTTL condition to an output that you define there. You can have as many outputs as you would like. Subscriptions are useful for cases when you would have a big organization with different teams within a same tenant, but your team would only be interested in the subset of those logs. Then subscriptions could be used for that case. So you would only get the logs that are really interested in you. And for the outputs, they are just basically correspond to exporters in OpenTelemetry. And one interesting custom resource that we have recently added was the bridge. So bridge is, for the OpenTelemetry folks here, it's basically a routing connector. We are using that to route a subset of the logs based on the same OTTL condition to a target tenant, from one tenant to another tenant. You might say that it's similar to a subscription there, but the core difference is that with subscriptions, we are creating a pipeline that we are using subscriptions, the tenants, and so on to create metrics based on which tenant was receiving the logs and collecting the logs forwarded to which subscription. So it's important for metrics. And with the bridge, you are not getting scrambled around with metrics. If you would to have a subscription for the front-end team subscribe to the platform team's tenant for the sake of getting a subset of the ingress logs, they would see metrics related to the platform team. And that's invalid because they are not part of the platform team. Yeah, let's see this in action. We're going to have a live demo session. I think I've lost the share. Okay, let's see this. As I said, we have an A/B button test for our front-end application, and everything is running in Argo. And what you have seen already were the subscriptions for the front-end team. We had a subscription for platform, also the tenants here, and also the bridge. And what you haven't seen is the main resource of the whole telemetry controller architecture is the collector. So with the collector, you have a couple of options to decide between which tenants to collect logs from. This is based on a tenant selector that basically matches on labels placed on tenants. You can have scenarios where you have multiple collectors collecting for you. It's useful for cases if you want to scale up. For control namespace, you're basically defining where to put your collector. And these are the flags that I was talking about, but more on that later. The final tenant that I didn't mention on purpose is the ingress tenant. If you have seen the routing done with this bridge resource, it's basically an OTTL condition matching on the server address set to front-end local. And that is going to allow us to route only the logs that has this field equal to front-end local to send those ingress engine access logs to the right place. And so we had to get our hands dirty and delve into how we can configure a transform processor within a tenant resource or within OpenTelemetry. This might look intimidating at first, but it's actually really simple what is going on. We are just basically putting away the body in a cache here under the key body string, and we are just splitting by double quotes. So we are getting the request line, which is basically going to be this whole here. We are getting the referrer and the user agent. We are putting away the user agent immediately, then the HTTP request, URL path, and so on. But the most interesting part is the server address coming from this line finally here. You can check out this in the demo repository. We give access to that at the end of this. And basically, this follows a basic ingress nginx log format, but you can always configure this with the config map that's getting deployed within your ingress nginx namespace. And that's basically how parse nginx works, but you don't just trust this. I could make 100 of errors in here with this parsing. And that's where this dry run mode and debug mode comes in with the collector. So what debug mode does is it basically just pops in a debug exporter at the end of the pipeline. But with dry run mode, we do something really crazy. I just have a handy command that I can just type in here, and I will get the currently applied OpenTelemetry configuration here. And we are going to use this cool visualization with AutoBin. As you can see, this is the pipeline that was generated by the telemetry controller by the resources you have seen before on the slides. So basically, we have, I hope it is visible. So we have this file log. So basically, the log source namespaces and the namespace selectors are like file log receivers because everything is on the nodes file system, as I've said before. And we have this one for the ingress, for the platform team. This is where you can see the bridge resource coming in with the routing connector and the condition that we've seen. And later on that you can see here the subscriptions, mainly for metrics and such, and so on. But at the end, you can see that we are routing everything to debug, and again debug. But you have seen that we were using file exporters and Loki HTTP exporters and so on. So what happened to them? Basically, that's the work of the dry run mode. So what we've done is that we replaced the production exporters. We've eliminated the persistence configuration. We've eliminated metrics and so on. So you basically get a sandbox-like environment where the OpenTelemetry collector is basically just bunching out all logs that are being processed. And if we just check this within the cluster, we can see that all of our logs that are currently flowing in the cluster is like all in debug. Why is that useful, you might ask? It's useful for checking whether we are having this singular line that we are searching for within our routing configuration. And if we just maybe get that pod and check the logs and just maybe grab for something that's we think it's inside our process logs, we can see that there's a couple of good parses here. So the parse is being done in a way that we would like to see. Like server address is pointing to logs front-end local in that side. We don't have a bunch of traffic on front-end local, but this shows us that we can be satisfied with our solution. So at that point, you can just immediately go in here, like maybe comment these one out, and everything is in Argo. So we can just maybe add this commit something like turn off, try, run, push it. And if we go back to Argo and just don't want to wait, yeah, the cluster was out of sync for a minute. And if we now check the OpenTelemetry collector configuration and pump it into AutoBin, now we can see that the pipeline became a lot more complex because we gave back metrics, we gave back the extensions, we gave back the production exporters, and yeah, that's the whole pipeline. So that's basically what you get with telemetry controller, like 500 lines of generated OpenTelemetry configuration. So yeah, that's the first part of what we've seen. And then I can continue the slides. Awesome. Okay, so now we are going to check beyond engineering. So that our great platform engineers were like basically helping the front-end team gain access to gain insight to the ingress logs. Now we have the chance to provide help to an imaginative marketing team that wants to gain insight to that A/B test application, which button was pressed more often, the green or the blue one, what was the malfunction rate, because buttons can sometimes malfunction, and they can check what's up with that. First of all, as I mentioned, I was interviewing with a couple of my colleagues, and they mentioned that most of the time when they have to deal with non-engineering folks, they often don't have an application. They have like needs of a produce of an application, more specifically metrics, analytics, or other types of information. So in the following example, we are going to have a marketing team that wants to run a new campaign based on which of the button presses was more popular. And the SRE team was given a task to find the best solution for that, more specifically helping them gain insight that they can understand. And the most handy solution would be to like create another handcrafted Grafana dashboard, but since they are a bit innovative in that manner and want to try new ideas, they go with Percy's, which is a fancy dashboard as a code application, which means that we are going to use YAML instead of JSON. So Percy, a few words about Percy. So Percy is a CNCF sandbox application that's basically a new kid around the block. It's quite new. I've been using the operator for this demo. Well, it's really new because I had to deploy the operator from source. They don't even have a helm chart at the moment. But besides those first bumps, the configuration with the custom resources was mostly easy. Here you can see the Percy server custom resource. We are having a data source, which is going to be used with Prometheus because the front-end application exposes metrics that we can use. Besides that, a couple of settings had to be tweaked around for the deployment, but everything was in order. Yeah, finally, let's see this dashboard as a code solution. So first of all, you need to generate some traffic, and sometimes the button doesn't work in order for the ingress to get some logs created. This is the front-end log viewer application that the team is using that basically just scrapes the file that the OpenTelemetry collector places down. And what you can see here is basically the dashboard that the front-end team is using. Once it loads, the ingress is slow. It's so slow. Awesome. No scraping has happened in the past 30 seconds, so we might as well just look at the metrics exposed by the OpenTelemetry collector that was created by the telemetry controller. Obviously, Percy's is a lot similar to Grafana in a lot of sense. They have direct migration from Grafana dashboards to Percy's dashboards. They are mostly focused on dashboard as a code and a widespread plugin architecture. I hope, metrics has arrived. So what is helping for imaginative marketing team here is basically there is a dashboard that is for them a link that you can send them, and they immediately have their insights, and it's everything there they can understand. How does this look like in code? Basically, as you would expect. So you have a dashboard as present as a custom resource, and obviously you have your variables, panels, and the layouts. While I was preparing, I was thinking about how it is possible to make a dashboard as a code more reliable or repeatable. Is there a chance we can template this somehow? And I came to the conclusion that is one of the hard parts of dashboard as a code. You can not really like template many of its parts, but obviously your panels and layouts can be templated. But when you come to the metrics, like that's something you cannot template. But that is like a shortcoming of dashboard as a code, but it's obviously for a prototyping solution like this, when you have to just give a quick insight to a team, it's something reusable. So yeah, that's basically it for dashboard as a code. Awesome. So a couple of conclusions I've collected by the end of this is that with telemetry as a code and the telemetry controller, each of the teams gets their own telemetry pipeline they can control, they can have their own data, but they can share them when needed through the bridge resources. And everything is familiar for SRE and platform folks. They just have to deal with Kubernetes resources. Most of the time, while we were having a chat with a couple of our users of the telemetry controller, they were saying that it's an easier solution for teams mostly in the prototyping stage, but when you have a stable environment You can simply just pop in the telemetry controller, and you don't have to like deep dive into the hard parts of OpenTelemetry. And also, it's multi-tenancy out of the box, basically, with the telemetry controller. You don't have basically namespace separation, you have tenants, and that is something that Kubernetes does not follow out of the box. And the final things, and the major ones I learned with this SRE journey, that is this everything as code basically works with all kinds of things, logs, metrics, dashboards. And it works because everything is in Git, everything is deployable, it's traceable, and this way observability doesn't feel that chaotic while I was, but my experiences was before as a software engineer. So this declarative nature makes it manageable and a bit more scalable through my glasses, at least. Yeah, thank you for listening. You can find my socials here. And if you are interested in checking out the demo repository or the telemetry controller, please do. And thanks.